Okay, so I was telling you that sometime it happens that this boundary line is below the origin, it's crossing the zero line. Then what is the meaning of this? This means that the impulse response is insignificantly different from zero. Impulse response is insignificantly different from zero. This is not significant. So here, in the beginning, the impulse response is insignificant and it becomes significant after a long time. No, you are below the zero. This means the possible response could be zero. One of the possible response, basically possible response is all this range, and one of the possible response is zero. Yes, yes. This is your optimal forecast, and then there are the bounds. Bounds are, optimal forecast mean maximum likelihood is corresponding to this, but it could be less, it could be more. No. Yes. If the blue line is intersecting with red lines, this means that there is no uncertainty. Yes. So anyhow, this is your impulse response analysis. Basically, if you do the same kind of analysis by using Ox matrix, what happens? You will get more beautiful graphics, which are more presentable in your thesis. The graphics of EVs are relatively um, not so having aesthetic value. So I will briefly tell you how to do the same kind of analysis in EViews as well. Sorry, we have done with EViews. I will tell how to do the same in Ox matrix. I could not get your question. Oh, we haven't discussed the variant decomposition, and it's a bit technical. We are not going to date because we have to cover one important topic after this. And okay, so now this is data in Ox matrix, and I want to apply the co-integration analysis by using this. You have to choose model for all modules, and then model for time series data. And now this is not single equation modeling. You basically want to estimate VAR, vector autoregressive model, which is basically multiple equation model. So you have to change this multiple equation dynamic models, formulate LGDP and LCONs. This is your VAR model. It will have roughly same kind of result what you get from EViews. But in EViews we have calculated the VAR with 2 legs, although it was indicating that there should be VAR with 1 leg. If you are also estimating VAR 1 in EViews, it must be same as the VAR in Ox matrix. So anyhow, once you have estimated this VAR model, you can go for co-integration testing, dynamic analysis and co-integration test. And I am choosing I1 co-integration analysis. These are your results. This is giving only trace test, not the max eigen test. And the trace test results are here. Look, the trace statistics is 6 and p-value is greater than 5%. This means that this is saying that there is no co-integration. And then there is the analysis, which is also available in eViews. These are the co-integrating vectors, 1 and minus 1.04. If you want, this is co-integrating vector is 1 and minus 1.04, and then you have CT and YT. So if you want to write the long run equation is like this: 1 into CT minus 1.04 into YT is equal to epsilon t. You want to shift this to other side, so CT is equal to 1.04 YT plus epsilon t. This is your long run equation. This is telling me that there is long run relationship in the long run relationship is basically not verified because there is no co-integration. But suppose you are having co-integration, then you can infer that this is the long run relationship, and you can base your analysis on the basis of this. And from this you can calculate the MPC as I have done in few minutes ago, right? But what I was telling you, the graphics of this are relatively much high quality. Let me see the graphics. I want to do the simulation and impulse response. These are the impulse response functions. This is going for very long. Actually, in eViews was giving you only for 10 periods. This is giving you for 60 periods. You can reduce this time period if you want. Number of steps, I can reduce this to 10. This is your impulse response function. Okay, it has same kind of interpretation which you have done in eViews. But the only difference is the graphics are relatively pretty to present in your, but there is no bounds around this. And if you want, you can ask the computer to produce bounds as well. Anyhow, this is how your co-integration analysis is performed. But the question is, how worthwhile is this co-integration analysis? I have told you this, that all this story started from the debate that the spurious regression emerges because of the non-stationarity. So if there is non-stationarity, you should go for testing unit root and co-integration, and if there is co-integration, then you can present a result. But the question is, last time we have seen the paper of Granger. The paper is saying that there might be spurious regression even with stationary series. If there is spurious regression with stationary series, then the co-integration procedure will not work. Then what to do? this possibility is not discussed in the literature in general. Why? Because all of the profession is having assumption that spurious regression is only a result of non-stationarity. So the entire discussion to deal with non-stationarity revolves around co-integration analysis. But as I have said, one of very great econometrician and a Nobel laureate and the pioneer of this co-integration analysis, Clive Granger, he is saying that the stationarity is also possible, spurious regression is also possible with non-stationary series, with stationary series. If this is so, then what is the need to do the co-integration analysis? We can illustrate this thing in a very simple way. Balki last time we have illustrated. Basically, if you have root equal 1, there might be spurious regression. If you have root less than 1, you can also see spurious regression. But the literature is not presenting any solution for the spurious regression when the coefficient is smaller than 1. And this man in front of you has invented a solution for that problem as well. And we will discuss and we will see how